series on geometric sequences and series. A sequence is geometric if the ratio of A2 to A1 is R, A3 to A2, R, A4 to A3 is R, so on and so forth. Obviously, R is not 0, but R is called the common ratio or common factor. So here's some examples. Let's find the common ratio for 3, 9, 27, 81. Well, 9 divided by 3 is 3. 27 divided by 9 is 3. 81 divided by 27 is 3. So this is a geometric series. And what that gives is n, or r, is equal to 3. So this would be set up as 3 to the n. The next one, we have 10, 20, 40, 80. So 20 divided by 10 is 2, 40 divided by 20, 2, 80 divided by 40, 2. So again, this is a geometric series, or sequence rather. And so in this case, r is equal to 2. Now, so the equation, and we'll learn this in the next lesson. The equation is going to be 5 times 2 to the n, because the 2 is the r, just like the 3 is the r. Here we have r is 2, so it's 2 to the n. 2 to the n, but we have to get the first term of 10, so we have to multiply it by 5. But we'll get into that a little bit later. And the third example, we have a negative 1/4, 1/16, negative 64. So 1/16 divided by 1/4 is a negative 1/4 is a negative 1/4. Negative 1 over 64 divided by 1 over 16, again, is a negative 1/4. And so r is equal to a negative 1/4. And so we can sum it up by saying it's going to be a negative 1/4 to the n. Okay, so finding the nth term of a geometric sequence is this formula here. A of n is equal to a1 times r to the n minus 1. That is, for example, we have a to the n is equal to a1 r to the 0, which is just 1, a1 r1, a1 r2, a1 r3, so on and so forth, till we get the a1 r to the n minus 1. So we want to write the first 5 terms of a geometric sequence where a1 is 2 and r is 4. So our formula, a to n is a1 r to the n minus 1, so we can write out a1 is equal to 2 times 4 to the 0. That's equal to 2. A2 equals 2 times 4 to the 1, which is 8. A3 is 2 times 4 squared, which is 32. A4 is 2 times 4 cubed, which is 128. And A5 is equal to 2 times 5. Oops, nope. 2 times 4 to the 4th. And that's equal to 512. So the next example, find the 9th term of a geometric sequence for a1 equals 4 and r is equal to 1/2. So we have the formula here, a9, 9th term. This is equal to a1 times r to the 9 minus 1. So that's equal to 4 times 1/2 to the 9 minus 1, which is 8. That turns out to be 1 over 64. So that's the 9th term. Okay, now let's find the 10th term of a geometric sequence, starting with a 6, negative 2, 2/3, so on and so forth. So the first thing we want to do is find r. So r is equal to a2 divided by a1, which is a -2/6, which is a -1/3. So now we have r, put it into the formula, a sub n is equal to a1r to the n minus 1. So a10 is equal to a1, which is 6, times r to the 10 minus 1, which is 9. And that turns out to be 2 over, well, it's negative, because r is negative. Forgot to put that in there. So it's -2 over 65/61. Okay, 10th term. Now, one thing to note before we go on to the next example, we have a10 is equal to a1 r to the 9th. And we can use this relationship for any number of terms, whereas 10 is equal to 1 plus 9. So we're going to use that pattern in the next example, where we're finding the second term of a geometric sequence is -18, and the fifth term is 2/3. And so we want to find r. And so what we're going to, the second and the fifth term are related by the formula. We can say a5 is equal to a2r, and this has to be cubed so that we get 2 and 3 is equal to 5. So solve this for r cubed. So r cubed is equal to a to the 5th, or a5 over a2. And a5 is given as 2/3, and a2 is a -18. So this gives r cubed is a -1 over 27. So we want to take the cube root of that, giving us r is equal to -1/3. Okay, now we can find, what are we trying to find? The sixth term. Okay, so put it in the formula. A6 is equal to A5 R to the 1, because we have A5, right? And we have A2. So A6 is equal to A5, which is 2/3, times R to the 1, which is just a -1/3, and that gives a -2/9. Okay, now we're going to look at the formula for the sum of a finite geometric series. We're going to call it S sub n. Now the series looks like this: A1R0, A1R1, A1R2, and we're going to sum all those up using this. And then turns out that this formula here, S sub n, is equal to A1 times quantity 1 minus r to the n over 1 minus r. Of course, r is not equal to 1 because we can't have a 0 in the denominator. So we're going to use that formula to find the sum of this here from n equals 1 to 7, 2 to the n minus 1. Okay, so we're going to write out the first couple of terms so we can get A1 and so we can get R. So the first term, 2 to the 1 minus 1, 2 to the 0, which is equal to 1. And the second term, 2 to the 2 minus 1, which is 2. The next term will be 4, and so on and so forth. And so A1 is equal to 1, and R is equal to 2 divided by 1, or 4 divided by 2. So R is equal to 2. And now we can just put it into our equation, S sub n. So we want to take the seventh, this is partial sum, so we have S of 7 is equal to A1 times 1 minus R to the n over 1 minus R. So that's equal to 1 times 1 minus 2 to the 7th over 1 minus 2. That turns out to be a negative 127 over negative 1. So the answer is 127. So now we're going to define geometric series, and it's just the sum of the terms of a geometric sequence. So our formula here, A1 times the quantity 1 minus R to the n divided by 1 minus R. If R, the absolute value of R is less than 1, which means it's a fraction, and as n goes to infinity, we have this equation here. And so we can say the sum, which is given as this, is equal to A1 over 1 minus R. And the series will converge to a sum if R is, the absolute value of R is less than 1. If the absolute value of R is greater than or equal to 1, then we know that the series just diverges. So let's look at some examples finding the sum of a geometric series. Here we have the sum of from n equals 0 to infinity of 10 times 1/2 to the n. And so in this case, we know A1 is equal to 5 and R is equal to 1/2. And so our formula, S is equal to A1 over 1 minus R is equal to 5 over 1 minus 1/2, and that equals 10. So this, because R is less than 1, this will converge to a sum of 10. Let's look at the next equation. So we have 5 plus 0.5 plus 0.05 plus 0.005 plus ... Well, so first we have to figure out what R is. R is equal to 0.5 divided by 5. That's equal to 1/10. And A1 is equal to 5. So our formula, S is equal to A1, which is 5, over 1 minus R, 1 minus 0.1, and that gives a sum of 50 over 9. Okay, our last example is finding a using compound interest equation. Now the equations we've used in the past, here A is equal to P times 1 plus R over N to the NT power, and we know that A is the amount of money you're going to have after time period T, P is the principal, which is the initial investment, R is the interest rate, N, number of compoundings per year, and T is the time. But this is only for one deposit, so only the initial deposit. In other words, if you have $10,000, that would be your principal. You put it in a savings account or an annuity that pays a certain interest rate, compound a certain number of times a year, but you're not adding to the principal. Well, now we're going to use this formula, but we're going to have ongoing deposits. So here's our example. You deposit $100 the first day of the month. Do that every month for 4 years. You put it into an annuity paying 6% per year, and they are going to compound it monthly. So if we look at the first deposit, the first $100 will earn interest for 48 months, and so A of 48 looks like that for just the initial deposit. Well, the second deposit earns interest for 47 months, So A47 looks like this. And if we were to do the last deposit, A1 is equal to 100 times R, which is 1.005 to the first power. So R is equal to 1.005. And so now that we know A1, put it into the equation. So S of 48, how much money you're going to have after 48 months, is equal to A1 times 1 minus R to the 48th over 1 minus R. And so A1, we know what A1 is. It's 100 times 1.005 to the 1 power times 1 minus 1.005 to the 48th over 1 minus 1.005. And you put that in the calculator, and the total amount that you have after 48 months is $5,436.83. So this is with depositing $100 a month for 48 months. That's how much you have in your account. All right, so that's it for 9.3.